I'd like to start with the title of this conference, which was A Quest for Legitimacy. It's a good question. Is management really a mature profession or an art? What do we need to become a profession? And in order to try and explain to you why I feel free to discuss that, I put on this slide my positions. My personal history has been as an engineer and project manager, then a professor of engineering and leader of a technical university, and most recently as chief scientist. I'm from the aerospace area, as you can see, professor of aerospace engineering, and in the aerospace area, projects are very large, multidisciplinary, multi-year, and if you fail in one of these projects, your industry can simply close down, and that has happened. Anyone who knows, for example, the Boeing surrounding in Seattle, you know that if Boeing loses a project, the price of houses goes down by 50% in Seattle within a year or so. One of the first jobs I got was run a big project like that, which usually takes 10 to 12 years, and I was said, okay, you have a little less time, you have 2 years to finish it. So you have to learn how to manage things without going to business school. And the results of not doing it right is here out of a big project in the US. I won't mention the names, I'll only mention good successes, not failures. And what the analysis of the failure was that what happened in this project was that the project-related tasks converged, managers attempted to design the system, and the designers attempted to manage. What happened is the project failed. So we need to discuss how this thing should work. And the issue I want to bring up is that business school students need to have some basis in the hard sciences, so to speak, and in engineering. And I'm going to ask here, how many people here have a degree in either physics, chemistry, mathematics, or engineering in the audience here? Ah, good. So I'm speaking to the converted. That's good. I would say it's about 1/3, which is very nice. And the reason this is so important is that analysis and problem-solving skills are basic to science and engineering courses from the start, and quantitative skills like mathematics and so, and the time for intuitive management, I think, is over nowadays. One has to be much more accurate and quantitative. Like I said, the skills are much more necessary. And another issue which came up yesterday by Peter Gomez is that scientists and engineers are trusted by the public. Statistics we made in Israel showed that 80% of the public trusts a scientist or an engineer when he says what things. Businessmen are only 50%, and we yesterday heard that it was 20% in the EU, so we are actually a little better. And it's closer in the public eye to politicians, which in our case, it sounded like 40, but I don't believe it. It usually is more like 4%, I think, in the world. So anyway, having an engineering background, a scientist background, will also help in terms of getting the public to understand and agree with management decisions, especially, and this is especially true in the developing world or emerging economies where scientific skills are even highly seen. And the last issue I wanted to raise was that the singularity is approaching. Now, I know that the singularity, as defined by Kurzweil, and I'm sure most of you have heard of it, is a very controversial issue. So I'm going to use a different definition of singularity. The way I see singularity is that by the time you've learned to use your cell phone i4, the i5 is out and it's different. So you have continuously to learn to use the equipment you actually have or want to use in terms of work, and never really can get the full potential of it, because by the time you've learned how to use it, and I used to ask the question of the audience, how many of you, when we all had VCRs, how many of you have graduated from the stage of having that little blinking light in the VCR and actually programmed it even once? And usually the audience says, hands lifted were about 10 to 15%. You don't ask it now because no one has VCRs any longer. We now have iPhones, right? So the point is that as the singularity approaches and things are developing much faster, much of the equipment we use and need, and especially the numerical equipment, is becoming user-friendly. And user-friendly is user-dangerous, because it means you don't really know what's going on inside. It's a black box for you. You get these nice programs, the different business programs and financial programs and so, but no one really knows what is going on inside those programs and how the black box works. So you trust what happens. And there is a very famous example when Texas Instruments still produced handheld calculators, these computers. A whole series of those came out with a little error in it. I hope all of you know that the sinus of 0 is 0. In this one set of machines, the sinus of 0 turned out to be 1. And they sold it, and after a while they started getting strange results and answers back, but no one actually doubted the fact that the machine is right, till they found out that things were simply really wrong. So that the problem of having too much technology can also be a major issue. I took this graph out of a company I'm doing, an Israeli company, which shows how important the mix of engineering or, say, hard mathematical skills and business skills come together. If we look at the abscissa, we see that the qualities of one of the types, the MBA, and the ordinate, sorry, the abscissa shows the engineer, the ordinate shows the MBA, but as you progress in the different directions in your profession, from starting to higher up in like corporate synergy or project leading, you need more and more of an interaction between the two, and the best interaction is if it's the same person, if he has the same qualities and can do both. Just to show you some of the symptoms of problems, as you mentioned, Israel is a specialist in startups, and I've been interested in that area for a long time. And actually, Richard, I wanted to suggest that as the subject for next year's Drucker Forum. Small companies, small and medium enterprises, and startups, as opposed to the large industries that Drucker and others have been working in as a new area. So this may be an interesting area for the future. What I wanted to show is that there has been a large number of technological failures at what we call stage 3, when there are about 15 to 20 employees. When the originator of the idea, who is usually an engineer or a scientist with no management training, has to control more than 5, 6, 7 people of different disciplines. You now have financial people involved and so on, and they simply get lost and don't want to, on the one hand, don't want to lose control. On the other hand, they get lost in doing that. And the statistics show that 1 in about 15 startups reaches the stage of beyond what we call stage 3, in other words, the second round funding, and maybe 1 in 20 to 25 actually returns money to its investors. And one of the main reasons is management. At that stage, entrepreneurial spirit and technical know-how is no longer enough. One needs the management skills, but unfortunately, at that stage, the companies are not big enough to have a separate management group. So you have to have this combined quality, and if you do hire a manager, he should have the technological understanding, at least, to be able to interact with the startup people on a real basis and not just be second-hand informed. Another issue that comes up is usually the loss of technological edge after the first product line. Because again, when a scientist or engineer develops something, he's enamored with it. It's his baby. And companies need to have more than one product, finally, in the end. And that's where the management comes in. But this type of manager needs to have the technological understanding to be able to point out the second product line. So identify the second product line and show how it fits in with the first. At that stage, nowadays, the S&T, science and technology personnel, are out of the decision-making loop, which again is a mistake, but as it's a fact of life, that as the financiers take over, we would like them to have the technological understanding, again, showing why this combination is needed. And a solution, notice the A. I should have put the A in a bigger letter because I'm sure there are different solutions, and I hope we'll hear some of them now here, is add more S&E studies, science and engineering studies, to management cadres in MBA classes and so on. Even just applied mathematics course, 1 or 2 applied mathematics course should be enough because that gives the possibility of understanding what the geeks are talking about. But a new problem comes up. As you may have noticed at the beginning, I said how to interest scientists and engineers in management and vice versa. Up to now, I talked about the vice versa, getting management people interested in science. But we need to do the other way around too, and how to get science and engineering students interested in that, and the practitioners, because I'm going to admit that as engineers and scientists, we tend to look down at these soft sciences and sociology and so on as the people who failed in high school and therefore went to study that. So we need to get out of that way of thinking. A partial solution to that is by adding salaries and prestige, because one of the major issues nowadays is that the salary of the management group is usually much higher than that of the engineering, and that may be one solution. But it requires different skills. And an inverse problem comes up, and that is, like I said, how to get management students and practitioners to develop more quantitative skills, even though some of them may really have been those who were afraid of math in high school, and still get them interested in that. Thank you.
Stay with me 1 second, Danny. One question I have is, as I did not study any engineer and so thing, in a few words, what could be the content of a today course for managers about science and engineering? It seems so broad, so large.
Oh yeah, actually, we didn't prepare it, but I had an answer.
All right, okay. So.
The first thing to learn is scaling. And that you can learn in an hour or two, that how to scale up things and what kind of rules there are for scaling. Just to give you an example, if you want to heat a room with a heater, with a flat heater, the flat heater has to be much bigger because its size goes up as the length squared, where the volume of the room goes up as the length cubed.
Yeah.
So that means that the heater has to be much bigger than proportional. Things like that, with some examples, would be very useful. Another thing is a little bit of differential equations to be able to analyze, and anyone in French schools knows that. It's easy, but other countries less.
We forget it very rapidly as well.
Yes. But a little bit of differential equations to be able to realize what gradients mean and what second-order gradients mean in order to control processes better.